Hey, this is Mr. Ward. I'm going to do a couple of short videos about level 5.5a, slope-intercept form. I realized I'd never made a video on this. So the slope-intercept form is right here. It is a way of writing an equation where if you know the slope or can figure out the slope and you know the y-intercept, you can make an equation for a line. Or if you happen to have the equation in this form, you will know the slope and you will know the y-intercept. So I'm going to demonstrate this in a couple ways. So you've got tables and so forth. We've also got some graphing. So let's go straight to some graphing. So I'm going to come up with an equation that has a y-intercept at 0, 7. So there's a y-intercept. I'm going to have to zoom a little bit like this. And we are going to try and get this equation to go through a point at 1, we'll make it 1, 9. Okay, so there's a point at 1, 9. So right now, if I made a line that went through those 2 points, I could just draw a line here, okay, like that roughly, okay. There's a line, and it's roughly going through those 2 points. So when I make that line, I can work out a slope. So so first of all, well, here's the y-intercept right there, because x is 0. So there's a y-intercept. And then I could work out a slope from 0, 7 to 1, 9. Vertically, I would go up. How much? I would go up 2. And then horizontally, that's positive 2. Okay, and then horizontally over there, I'm going to go over 1. So notice I'm making my flow in the same direction from this point to this point. I could have gone the other way, and I'd still end up getting the same answer. So my slope should be 2 over 1. That'll be my slope, change of y over change of x. So m is going to equal that. Okay, so the slope-intercept form allows me to take that information and create a line that goes through those 2 points. Let me actually erase the line that I did, okay, because it'll get in the way. Okay, so we worked out the slope for that line, and the slope for that line is 2. Okay, 2 over 1, which is just 2. So we're going to say y, we're going to use the equation form y equals mx plus b, and we're going to replace m with 2, and we replace b with this y-intercept of 7, and we made a line that goes through those 2 points. Okay, now I'm going to make another line, and I'm going to obscure what's going on in the graph. I'm going to say y equals 1/3 x minus 2. Now that line, what I now can tell you is this line, because this is in the slope-intercept form, y equals mx plus b, in the slope-intercept form, the slope is 1/3. I know that. And I also know that the y-intercept is at 0, -2. That negative means I'm adding a -2. So I'll plot a point, 0, -2. And then let's plot another point. If the slope is 1/3, what that means is I could go up 1 from -2 and over 3 from 0. Let's see if we can get 2 points that will be on this line without looking at the line. Okay, so up 1 from -2. Okay, so I'm going to deal with the y first. So up 1 from -2, because the numerator has to do with the y part, is going to be -1. That's 1 higher than -2. Okay, and then over 3 from 0 is 3. So let's see if that is in fact on the line. Okay, the line is down below. I'm going to erase all this stuff here. Okay, and let's see, big reveal. And in fact, yes, it is. So the line goes through 0, -2. That's the y-intercept for it. Look, there it is. There's the y-intercept for it. And it has a slope of 1/3. So we go up 1 and over 3. Okay, I'll draw that. So we go up 1 from -2. That's the vertical change. And over 3 for the horizontal change. So up 1, that a proper 3, up 1, and over 3. Now, since it's the slope is 1/3, I could get an equivalent fraction, and maybe I could call that 3/9. So let's see what happens if I go up 3. So up 3, and then over 9. So I went up 3 from -2, so I'm at 1 right there. That's 1. And so I went up plus 3. And this is something you can do with slope. And then I'm going to go over 9 from 0. So I should end up at 9. So let's go over 9 places. Okay, all the way over to there. And in fact, I should have a point right here at 9 for x and 1 for y. So let's see if I do. Let's see if that actually is on the line. 9, comma, 1. And in fact, it is. There it is. 9, 1 is on the line. I could work backwards with this as well. I could go, I could take 1 over 3. I could turn that into -2 over 6, for example. So let me move this over. I think I'm going to have to erase some stuff now. Make that go away. Let's see if we use the equivalent fraction for 1/3 of -2 over -6, and we go from right here, we go down 2, which gets us to -4, and then back 6, which gets us from 0, which gets us to -6. And looks like it goes through -6, -4. Let's see if that's true. Okay, and all I did was I subtracted 2 from -2 to get to -4, and then I subtracted 6 from 0 to get to -6. So let's see if that's true. It looks like it's true. -6, -4 is on the line, and we are good to go with that. Okay, so that is really the basics of the slope-intercept form, but there is, this is important for the testing out on it. Let's talk about how to deal with the slope-intercept form from a table. So I'm going to create a table. And if we have a table, and this, I've got a table, I'll say -10. These are going to be my x, y's, -5, 0, ... Okay, so I didn't go by ones. Over here, I'm going to go 3, 6, 9, 12, 15. You might notice I'm going by 3s. And so so remember that a table is just a stack of ordered pairs. So everything on here is an ordered pair. So here is -10, 3. That's an ordered pair there. This is 5, 12. And I have set this up to be a linear table. And you can kind of verify that by zooming out, and you'll see these dots that are all lining up in a straight line. We can figure out the slope from this table, first of all. So let's figure out the slope. From 3 to 12, that's going up 9. So that's 9. And from -10 to 5 is going to be up 15. Okay, so that's 9 over 15, which is the same as 3/5. I could pick another pair of points. So there we go. From 15 to 18 is up 3, and 10 to 5 is up 5. And that's 3 over 5 is an equivalent fraction of 9 over 15. So let's plot that. I'm going to have to erase some stuff. Okay, so we'll plot that. We figured out a slope that was 3/5. Okay, so that's part of the way there. So remember, we've got this equation form that goes y equals m for slope times x plus b. Okay, the m times x that's we're multiplying a constant rate of change of, in this case, 3 over 5. Okay, that's a constant rate of change. That means we're adding 3/5 repeatedly. Then let's figure out how we get the y-intercept. Well, when you look at this table, if you want a y-intercept, you want to find where x is 0, 0, 9. If you go over and look on the graph, you can confirm that 0, 9 is on axis. So if I want a y-intercept, it's right here for me, 9. So I'm going to add 9, and there is a line that goes right through all those points. I have found it from a table. I'm going to stop, and then I'm going to do a second video about the laser cannon battle commander. I hope that